Right. Good evening, Kutala. Am I audible? Okay. Right. Now, what about the networking? Hmm? Can someone explain what is a topology? What's a network topology? Right. Last 2 3 days, right? Not last 2 3 days. Whole month we are talking about networking. It's computer networking. So this is a small question, right? What's a network topology? අලුත් පුතෙක් ඉන්නවනේ අපි එයාට එක්ස්කියුස් කරමු. So others, Kutumya, Mutuli, Dasuni, mm, so today, right? What's a network topology? Banta verla anda puta. Putala in this ICT, right? You can't remember everything because it's a sort of a foreign thing to you all, right? It's a sort of so every day you're getting new things. So it's not in your blood, right? So you can't remember. Don't try to remember these things. පුතාලා මේ ඔක්කොම මතක තියාගන්න යන්න එපා, right? So once you become IT expert one day, right? Someday you will remember these things, right? But don't try to remember as it is. මේ ඔයාලා memorize කරන්න හදන්න එපා as it is because this is new thing. It's a really hard effort, right? It's a really hard effort. And maths ගත්තොත් ඔයාලට පුරුදුයිනේ, right? So maths, so you did it from your maybe nursery level, right? So now you can understand something someone says, even the advanced things you can understand, right? So computing, it's a new thing, right? If I say computer network, sometimes um, it's the very first time you are listening about that, right? So don't try to remember these things. So instead, what you can do, you match these things to your day to day, the non things, right? So that's why I asked, what's a topology? It's a sort of a technical term, right? Network topology, it's a technical term. It's very difficult if you don't study or if you don't remember, right? You can't easily answer that question, right? Instead, you can නේද පුතාලා ඒක මතක තියාගන්න බෑ, right? So instead what you can do, um, relate it with your day to day life, right? So, topology is a pattern. It's nothing but the pattern. So network topology, it's very simple, right? So how? So network is it's a combination of computers, interconnected computers. So what does a pattern mean? So pattern means the way computers are connected. That's all. So it's a pattern. So how computers are connected. So in which pattern? So you're going to build your network, right? So now I'm going to draw a small pattern. So I have a central something box that we call it as switch, right? And I'm going to connect computers like this. So this way, right? So there's a pattern, right? What is this pattern? Now we learned few patterns. No? There are few ways we can interconnect computers, right? What is this pattern? Can you identify? පොතේ නැති එකක් යන්දේ. Right. Tinuka පුතා. Straight away, this question goes to you. What is this topology? පොතේ නෑ. මුතුලිදුව, you was telling something, right? What are the four topologies, five topologies we learned? Tell me. What's the first one? So, how many patterns we discussed? Network. Few network patterns we discussed. Network topologies. Right? So, how many topologies or the patterns we discussed? The Hitian and the Melamai. Ah, five. Right. So, what are the? Tell me one or two patterns. Mm-hmm. Right. Right. We discussed about five topologies, right? So, then tell me what's in the board. Star topology. Good. Why? Because so star topology, Putala, you can understand easily. So it's surrounded by a central hub, right? All the computers are surrounded. So, right? Don't confuse that this pattern, right? It's not like a star. This pattern. So something, but you need to understand how the computers are connected. So all the computers are connected to a central hub, central position, right? So don't expect this kind of star illustration or the figure. So then you will tell this is a star topology, right? Don't expect this kind of figure. They won't give. Sometimes they will give like this. But here also see, all the computers are connected to a central point, right? Still this is star topology. Don't expect this star kind of illustration or figure, right? Okay, star topology. So basically, this is the most common design we can find even in the enterprise world, right? So this is the most commonly used topology. So they will ask sometimes, right? Sometimes they will ask to explain about the topologies. So you need to maybe they will ask any three topologies you have to explain. So you have to um, draw this picture and you have to explain, right? So you have to tell, right? In that case, you have to tell it's a centrally connected computer is the most commonly used network uh, pattern or the topology, right? Uh, so basically, uh, we use central hub as a hub or switch for central, may make the central connectivity. So that's the star topology, the explanation, right? And the next one is bus topology, right? Bus topology, we have um, main cable. That's my just. So that's why it's called bus topology, right? So there's a main cable, right? It's like a. I told you, no, last time. It's like a water main water line, right? So you can tap here and you can get some connections. So like this, right? You tap here, you get some connection. Similarly, right? There's a main flow, right? There's a main flow, right? So you just through this connectivity, right? There's a connecting method, right? So you can establish network connectivity to these computers, right? So this is bus topology, right? So main bus or main cable is being used to establish the network, right? So one disadvantage is if any breakdown uh, of the main cable causes disconnection of the remaining network, right? So let's say we have 5 computers, right? So if something goes wrong here, let's say your main cable broken down here, right? So afterwards you won't get the connectivity between these two computers, right? So any disconnection of the computer network, the sublines won't impact the other connectivity, right? Sublines, these are connections, no? ඒක නිකන් ඇවිල්ලා ඔයගොල්ලන්ගේ ගෙදර ටැප් ලයින් එකක් කැඩුනට අනිත් අයට වතුර තියනවා වගේ. හැබැයි මේන් ලයින් එක කැඩුනොත්, right? So the remaining people won't get the water supply. So that is bus topology, right? Ring topology. So all the computers are connected in a circular way, right? Circular way. So I'm just quickly going through this, right? So the network flow, the data flow. So why we need networking? To exchange data and sharing the resources. That's the main purpose of networking, right? Exchange data. So this is computer A, this is computer B, this is C and D, right? So we can exchange the data. So A, B, C and D exchange their data, right? So that's the main purpose of networking. And let's say we have a printer here, right? So printer we have. So instead providing printer to each and everyone, right? So we can have a shared printer, right? One printer. So all the 4 people can take printouts through this printer. It's networkly connected, right? It's connected to our network, right? Uh, just talking about ring topology, right? Right. Here also same, right? The breakdown of the cable, right? It will impact the entire network. It will impact the entire network, not like bus topology and the star topology. So any breakdown causes a complete network breakdown because it will break the ring, right? So the ring is disconnected. So you can't exchange the data in this manner, right? Because data is flowing in one direction. So any breakdown of this network cable causes data transmission issues, right? It's breaking down, right? So that is ring topology. What's the other one? Okay, tree topology. Uh, Actually, it's a combination of both bus topology and the star topology. Star topology, now you know, right? It's centrally connected to computers, right? This way, and there's a main line backbone. We call it as backbone, right? So there's a main line. It's like your nerve system, right? And few more star topologies connected to the backbone. See, this is bus topology. This is star topology, right? So it's a combination of both bus and star. So breakdown of this point only disconnect the main network. So it's like as example you take our SLT network, right? So they have their own backbone, right? All our organizations are connected to their backbone, right? So if something goes wrong inside our organization's network or the main cable, so it won't impact to the others. But if something goes wrong with the main cable, will impact to the other network connectivities, all our network connectivities, right? Uh, there are advantages and disadvantages both you have to discuss, right? So basically these are LANs, local area networks, right? In other words, different organizations maybe, right? So connected to the main backbone cable, right? So inside the company, or if it's a single organization also, we can build this kind of network. Let's say we have a five-story building, right? So we lay one backbone cable, right? And we connect star networks like this. That also one way of doing the network, right? So don't stick into the pictures given in the book, right? So they some the new ways. If they give new type of questions, you will get confused, right? Stick into the theory, right? So if it is bus topology, you need to find the main cable, right? And the last one is mesh topology, right? So all the computers are interconnected with each other, right? So let's say this is computer A, B, C, and D, right? A is connected with all other three computers. B is connected with other three. C is connected with other three, and D is connected with other three, right? There is a mesh, right? So it's a uh, This is sort of a complex connection, right? This sort of a complex connection connectivity, but the failure rate is little bit low compared to the other one, because let's say if this line goes down, still there is a way to reach the other person. See, right? So if this goes down, see, still there is a way to reach the this peer, right? Right. So now two connections are down, right? This is down, this is down. Let's say this is also down, but still each other can talk, right? Three connections are down at the moment, but still um, computers can talk, right? So what's the best example for mesh topology? Give me one example, best example for the mesh topology. හොඳට මතක තියාගන්න mesh topology එකට හොඳම example එක තමයි very good. Internet. Internet. So it's a connection of combination of billions of computers together, right? Even your mobile phone is part of a internet, part of this mesh network, right? So it's a network. It's the biggest network in the biggest computer network in the world, right? That's nothing but internet. So mesh. So we can't say it's a star topology. So you don't know how it is connected. Anyway, it's connected, right? All the equipments are connected. So basically, it's happening through a mesh connection, right? So remember these things, right? So we discussed, right? Last week we discussed throughout the lesson. We discussed these five, right? So today, benefits of networking. So benefits. Tell me few benefits, Kutala. So already you know two things now. Benefits. මේවනම් කියලා දෙන්න ඕනේ නෑ නේද? You can think and write these things, right? Benefits. Exchange data. That's the biggest benefit or the advantage. Second one, we can share resources, right? Share resources. And we were talking about client server computing. Did I? I'm explain the client server computing. Right. So we have one server and we hosted one central software, right? Let's say 100 computers are connected to this server and they are making use this central software, right? So the central software is serving the what's the biggest, I mean, most suitable example for this banking system, right? So let's say, for example, we have bank called XYZ, right? Their head office they are hosting one central software, that's called core banking system, right? Core, right? Centrally they are hosting, right? They have very big data center servers, right? So at head office level, they host one central software, right? All other branches can get the information. So these are branches, right? Let's say throughout the country, right? They have 100 branches, right? All 100 branches can get access this central software, the core banking system, right? So that's one benefit, right? Thanks to the networking concepts, right? We can get the advantage of central software accessibility, right? Central software. Otherwise, we have to install that software to all these banks. So maybe 2 decades back, we had that kind of situations, right? Each and every branch got their own computer system, right? Those are not connected. So the client benefits were limited at that time, right? So you must go to your I mean account opening branch to do whatever your banking things, right? Right. So if you are from let's say Candy, right? So you must go to the Candy branch. You can't go to Colombo branch and access your data because at that time they were not connected, right? So thanks to this the advancement of central software and the servers, right? The networking things. Now we can even say the Jaffna client can access the data from Colombo or the Matra itself, right? So throughout it's anyway it's connected. Not only if they have overseas branches, right? They also can. Let's say they have UK branch, right, or USA branch. So we have no some of our banks are operating in overseas, right? So they have UK branch. So still they can access our local data. So that thanks to the networking concept. So ability to access the central software, that's a big one of the biggest advantage with the networking, right? Uh, what's the next one? Ability to connect at anywhere and anytime. Hmm. Connect anywhere, anytime, right? So you all are now going online, right? Whenever you want, right? Take your phone or the computer, you go online, right? Not only you guys neither. අම්මිලා තාත්තිලා ඔක්කොම එහෙමයිනේ ගත්ත ෆෝන් එක ගියා online. So you can connect anywhere at any time. If you have data, you're done, right? So that's the uh, advantage of networking, right? So your phone is connected to the internet, so you can browse or you can access the resources through your mobile phone. So that's very convenient way of doing your daily stuff, right? So thanks to the networking, right? And the security, right? So the next one is security. That is very important topic, right? Networking security, right? Now you see here, right? If you are connected, interconnected, let's say if you are here, you are alone, you are standalone, you don't have any accessibility, right? You are standalone here, right? You don't have any security threat. As soon as you connect to the globe or the internet, right? Currently, you don't have any data connection in your phone, right? So now you are secure. Why? No one can um, access or threat your phone from the outside because you are standalone here, right? You are alone here, right? As soon as you connect to the internet or the globe, right? If you establish the network connectivity, things anything can happen because I know. Uh, I told you, no, not only good things happening through the internet, most of the things are bad, right? Relatively bad, right? So there are people called hackers, and you get malwares, you got Trojan horses, sort of ransomware, different types of viruses, right? So unauthorized people, they're trying to get advantage of someone's resources, right? So they if they have access to banks, so they're trying to break down the services, right? They're trying to access the maybe bank accounts, right? Uh, they're trying to they demand money, they demand ransoms, right? They demand. So they do various things, right? Maybe for entertainment purposes also they are doing some, right? And lot of things are happening inside the internet. So you need to be very careful. So security becomes one of the biggest challenge, right? Thanks to the network, right? Security is enhanced. So security protocols get enhanced due to the networking. So when the networking becomes the maybe banking system maker, right? So when the things are getting connected, right? So the security specialists, right? Uh, they will also think how to increase the network security um, settings of this network, right? So you are growing up now. So your small network now you getting bigger and bigger, right? So there's a threat of um, getting unauthorized access, right? So the security also need to be implemented, right? So then the security become a most uh, important aspect in terms of networking, right? Uh, So there are so many ways that we can secure the networks, right? So your password, so a strong password. So through that you can, there are some concepts called two-factor authentication. Maybe you're getting OTP when you're doing banking transactions. They will check whether the real person is doing the transaction. So the best way is getting two-factor authentication. They will send token to your mobile phone, the registered mobile phone, right? So with that procedure, they will eliminate the other unauthorized access. So that benefits you can get because of the networking, right? So security. And the electronic mail. The next one is electronic mail, email. I don't want to tell that. No, email is very important. Everyone is getting email now. So what's the format of the email? Tell me what's the format of email? කොහොමද email එකක සාමාන්‍ය format එක? එහෙනම් email එකක් තියෙන්න පුළුවන්ද? XYZ. Can this exist as an email address? And then tell me the format. Email is just like your home mail address, right? You should tell the location, right? Uh, so in regular mail, we say 25, let's say Main Street, Candy, right? This is our regular address, right? So the postman or the postal department won't look at who is receiving the mail. First, they will look at the Sri Lanka. So, as an example, you are getting overseas mail, right? First of all, they will check the last destination, Sri Lanka. They won't check the name or the home number or the street address, nothing. So they will just first check what country it belongs to, right? So you are sending mail from UK, right? The UK Postal Department immediately ships all this mail to the Sri Lanka. They won't consider this part. So our central exchange receives. So now they don't want this one, right? They will, the central exchange, the Colombo one, right? So they don't care about this part. They will throw these mails to the Candy postal department. Now Candy postal department has the rest of the things. So they have they need to deliver to the correct address. So this part is important to them, not the other people or the central exchange or the Candy. I mean UK postal service or the Sri Lankan central exchange, right? Understood. So similarly, email address also got some destination, right? So one of the most popular email service is Gmail, right? So I will take that example. So xyz@gmail.com. So at this is called domain name, right? At followed by the domain name. At this is must, right? And your domain name is required. So this will take care by Gmail. First of all, Gmail should receive the email, then Gmail will validate whether I have a person called XYZ, right? Similarly, you got Yahoo, yahoo.com. This is not so popular now, right? So at yahoo.com. So if someone at gmail.com wants to send us, so let's say abc at yahoo.com. So xyz at gmail.com wants to send mail to the abc at yahoo.com, right? So straight away, Gmail will throw this mail to the yahoo.com, right? Then Yahoo will check whether ABC is exist in their domain. If not, it will discard the mail. Otherwise, it will deliver to the mailbox. That's how. This is a very simple explanation how mails are getting delivered, right? So if I say Gmail, it won't go to anywhere. As if I say Candy, it won't go to Jaffna, right? So definitely it will go to the direction and it will check whether XYZ is exist, right? So that's the concept behind the emails, right? So you should have sender name at and followed by the domain name. At is mandatory. Without at, email won't work, right? So xyz at gmail.com. That is valid email address, right? So this receiver's name or the name at and the domain name. So this is the valid email address. So we have different lesson in internet and email. So at that time we'll discuss further, right? So we have hundred thousands of email domains, right? Each and every company got their own email addresses, right? So I can get my own. If I establish organization, I can request. The only requirement is it should not exist in the world, because two gmail.coms cannot exist in the internet. Two gmail.coms, because it will conflict, right? Sender will confuse. It won't allow you to create, right? So I can't create now gmail.com, right? If I want to, also it won't allow. It will say it's already exist, so you can't create. You create something else, right? So two domains with the same name cannot exist, right? So that is email, the format of email address, right? So email is a um email is possible due to networking, right? So it's a advantage, it's a benefit because of networking, right? So similarly, we have disadvantages also. What are the disadvantages? So the first one is security, right? We discuss about the benefit. Similarly, security become disadvantage also, right? I told you, no? Threats are happening, right? Security can effectively manage because of networking. The other hand, security becomes the highest threat to the network, right? So, I mean, sorry, security become the highest concern to the networks. Network security is a we should have very high concern about the security things when we are operating or managing network, right? So anything can happen, right? So we have organization, right? Internally we are managing, we are exchanging data, so we have printer, right? Nothing will happen. As soon as you connect to the internet, right? Things getting started, right? Viruses can come, hackers can try to access your data, right? Maybe someone can send your data to some person, so illegally. So you have very sensitive data here, right? You are protecting, right? So your employee can send data to someone, right? Illegally. That's called data leak, right? Those kind of things also possible because of the networking. So security, right? It's a major concern with respect to the networks, right? uh, right. And the second one, uh, breakdowns. So we discussed few breakdowns, right? Any topology can go down due to in various ways. The advantage is we can minimize. So depend on the technology we use, depending on the topology we use, we can minimize the breakdowns, right? But breakdown can happen. So breakdown also here is our example, right? So this is our banking system, right? So we have Kandy, Jaffna, Mathura, Colombo. So we have branches, right? So breakdown of Kandy network won't impact the other banking operation, right? But breakdown of central system, right? Central, let's say that their connectivity goes down due to flooding, right? Everyone get affected. So the bank cannot operate because this central it's impacted, right? So anything can happen, right? Don't think only they will survive, or it's not like that. If centrally goes down, right? So because of that, they maintain redundancies, right? They maintain redundancies. They create one more site. They're spending a lot to maintain that, right? So these people doesn't know about that. So they are maintaining the replication of their central system, a copy of no, the replication already in copy of their central system. May copy maybe let's say this is in Colombo, right? Maybe they are keeping this in Gampa. So they have a copy of the central software. They are keeping secret, right? It's getting replicated. All the transactions getting copied to the same time, real time. It's getting copied to the Gampa, the redundant data center also, right? So something happens there, right? So automatically these clients will connect it to the right seamlessly. They will connect seamlessly. They will connect. They don't know it. Some what is wrong with the central. It's working with the central system or the Gampa system. They don't. They they're not worrying about, right? They don't know seamlessly. It's internally it's getting transferred. So thanks to the networking, right? But when you are writing answers, make sure if they're asking disadvantages, right? Breakdown of the net core system can cause the entire network breakdown. So you have to write the answer like that, right? Both ways you have to match the answer, right? So security can be advantage, security can be disadvantage, right? The breakdown, um, the ability to connect the net it's advantage, but the breakdown can be a disadvantage. So that way you have to match the answer, right? And the third one, viruses. It comes in the security, no, right? No need to explain. So once you are connected to the network, so viruses can spread. So virus is a, it's a sort of a software. It can spread through the connections, whatever the visible connections, it can travel autonomously, it can travel, right? No need someone to, I mean, send. It's automatically, it's getting copied, right? It can develop itself. That's how viruses are getting spread. Then viral flu එකක් හැදුනත් එහෙමනේ, right? So one viral will come and resides on your throat, then it will develop itself, right? So similarly, if computer virus also, that such programs, right? Let's say Candy, one of the person in the Candy uh, brought virus software, right? Then copied to his computer, and through the network, it started spreading everywhere. So viruses can, there are types of viruses, right? So local viruses, it's automatically spreading viruses, file deletion viruses, right? So file converting, the encrypting, changing the file type, that kind of, so many things are happening due to virus issues, right? So virus, anyway, in general terms, virus is a harmful thing to the computer world, right? So um, viruses can spread through the networking. So because of the networking, it can uh, easily get spreaded uh, to all the computers, right? So if you don't have this connection, it can't go to the Jaffna network, no. But since you are connected, it can quickly spread to the other networks, right? If you are alone, it cannot. But if you are connected, once you are connected, it can spread to the other locations, right? Viruses. Uh, Computing, they are talking about the client central server, central system breakdowns. I explained that one, right? And the training requirements. Uh, because uh, let's say organizations, right? So they want to train their employees to work. It's a sort of different way of working, right? It's not like operating individually, right? So uh, networking concepts, we need to train the people, right? uh, and there we need sort of specialized people to manage this kind of situations, right? You know, you have to take care about the security requirements, the performance. We need to maintain the performance, right? Performance of the network connectivity, right? Otherwise we can't wait for years to get the data from, say, head office, no, right? Um, so performance need to manage, and the activities need to monitor, right? What people are doing, right? And sort of virus security activities need to measure and take corrective actions, right? So for that we need to maintain specialized staff to manage the networked environment. So that is one. That telling it's a disadvantage. Yes, it's a costly thing, right? So when your network becomes bigger and bigger, you need um, you need to spend lot to manage that sort of network. නේද? දැන් ගොඩාක් මේ network එක ලොකු වෙන්න. So they need to hire specialists, right? And a lot of the IT staff, employees. So the training requirements also getting increased, right? Both employees and the IT staff, we need to train, right? So there's training requirements. It's not a anyway, it's not a disadvantage, but it's a costly thing. So that's what they are mentioning. So uh, with that, we can conclude our longest chapter. හරිද? තියරි ගොඩාක් තිබිච්ච chapter එකක්. ඔන්න අපි මේකත් එක්ක අද ඉවර කරමු. right? So networking, it's done. ये සතිය මම පොඩ්ඩක් ආව නේද අපි තව චුට්ටක් වෙලාව තියෙන නිසා ඒක පොඩ්ඩක් රිෆ්‍රෙෂ් කරමු, right? So now we can start the number systems, right? මේකට එන්න කලින් networking වල තියෙන ප්‍රශ්න අහන්න. any issues, any තේරුම් නැති තැනක් තියෙනවද? දන්නව අහන්නේ නැහැ කියලා. මම ඇහුවේ නිකන් අර හරි නැති හින්දා. හොඳටම තේරුණා. අනිත් දවසේ තහනම් WhatsApp network topology කියලා පටන් ගත්ත ගමන් ඈ. හොඳට කල්පනා කරලා බලන්න ප්‍රශ්න නැද්ද කියලා. හරි. නිශ්ශබ්දතාවයෙන් පෙනී යන්නේ ප්‍රශ්න නැති බවයි. Let's move into the number systems. On අපේ third lesson එක, right? Right. So it's not this is not the topic, right? So the book topic is data representation methods in the computer system. So different data representation methods, right? So when it comes to computers, right? Number systems. මොනවද පුතාලා මේ number systems කියන්නේ? So number systems තමයි මේ short topic එක, right? Data representation, right? දැන් පුතාලා දන්නවනේ computer එකේ function එක. So what's the basic function of a computer? Input. Right. Input, process and output. Input, process and output. So you need to enter or input data and the instructions what to do, right? CPU does the processing and you can get the information, the process data info, process data, right? Process data. So here you are entering raw data, right? So this, the electronic device called central processing unit, it will process the data according to your given instructions and it will give you output. Those are called process data or information, right? Then mama කියනවා 2 plus 3. So 2 plus 3. So what CPU does? It will add these two numbers, right? And it will send, let's say output is our printer or monitor. It will display as 5. Right? So this looks like a data again, but it's a information with respect to this නේද? 5ක් කියලා ගත්තොත් ඒක still a data නේ. ඒක raw data එකක්, right? We don't know what to do, but so you have to match with the instruction given. So with these two facts, right, this becomes a information. That's how you segregate. Otherwise, this is raw data again, right? So data and instruction we have to provide. CPU does the processing and get the output as a information. So process data, right? Uh, right. So how to input data using input devices. Input devices. Tell me a few input devices. Input devices. Keyboard, mouse, right? So we can enter the data and instructions through keyboard mouse, right? So still CPU is doing the processing part, and here storage also key function, right? Input processing output is the main function, right? Storage also the main function, right? So you have to remember that, right? CPU does the processing, and output devices we can get the output through output devices like monitor, printer, uh, a scanner, right? Scanner, right? Scanner का input output device है नहीं दो दस नहीं दो तेरे होता scanner input the output the confuse मुका the scanner क्या है आगे तो input device है अनिता input device है scanner is a input device where you can scan or you can copy the contents of a paper and you can feed to the computer. So it's an input device. So yeah, good. Right? It's an input device. So scanner is wrong, right? So here scan is input device, right? Keyboard, mouse, scanner, light pen, maybe webcam, right? So many input devices, right? So then Putala, right? So you have a clear understanding about this, right? So gradually we are entering to the lesson, right? So we have input, process, and output circle, right? So input, right? Using keyboard. Alright. So keyboard still it's a electronic device, right? Is it? Right? Computer is electronic device, so keyboard becomes obviously it's an electronic device. Without electricity, it won't work, right? So we have connected keyboard to the computer, and I'm going to press A, right? Now I have a keyboard here, right? Right. See, this is my keyboard, right? So I have connected this keyboard to the computer, right? And I'm pressing A. So what will happen? A goes to the computer. A goes to the computer. हम हमारे इधर A press करा मैं A computer के अतुलटे आनो हमारे इधर එතකොට ඒ කියන්නේ මේ වයර් එක කපලා කවුරු හරි බලන් හිටියොත් ඒ අකුරක් හොයාගන්න පුළුවන් වෙන්න ඕන. මේකෙන් ඒ අකුරුවේම එනවා බලා ගන්න ඕනේ නේද? මේක ඔබද්දි මේකෙන් ඒ අකුරු එළියට එන්න ඕනේ. Right? So it's not happening like that නේද? ඒ press කරාම monitor එකේ ඒ අකුරු වදින එක හරි. So output device එකේ it shows as A. But what happening in between? Right? So when you press input, this is our CPU. CPU does the processing part. So it can't straight away recognize this as A. And the electronic device එකක්නේ පුතාලා. So this won't recognize A, right? So what will happen? So there is a, when I press A, there is an associated number, right? There is an associated number, let's say 65, right? This is happening inside the keyboard, right? 65, it's getting converted to the digital form. So computer is it's a digital equipment, right? So digital means only it can handle two states, digital, right? Two states. What's our states? Ones and zeros. Computer knows only ones and zeros, nothing else, right? Whatever you input, you need to convert that to ones and zeros, right? Ultimately we can't send ones and zeros to the computer. එහෙනම් අපි අර A එක ගහලා බලන් ඉන්නේ නැති ones and zeros යනවා පේන්න එපා. එහෙම වෙන්නේ නැහැ, right? Ones and zeros it will represent as electronic pulse, right? So let's say 5 volts and 0 volts. So 5 means 1, 0 volt means it's 0. So it will convert to the electronic signal. It will send the electronic pulses. චූටි කරන්ට් එකක් තමයි යන්නේ. 1 වෙනුවට කරන්ට් එකක් යනවා, 0 වෙනුවට ඊට වඩා වෙනස් කරන්ට් එකක් යනවා. Two states, right? ඒක මේ අතට වදින ලොකු කරන්ට් එකක් නෙවෙයි, it's a DC current, right? Very sensitive small current එකක් යන්නේ, right? So it's a, let's say 5 volt represents 1, 0 volts represents 0, right? So if I want to send 1010, it will send 5 volt 0 volt, 5 volt 0 volt. මේක volts හතරක් මේකට යනවා. Right? So CPU will understand. So it's coming 5 volt 0 volt 5 volt 0 volt and මේ එකතු කරන්න කියලා කිව්වහම so different pulse it will get. Right? එතෙන්දී මේ හැම එකටම number එකක් තියෙනවා පුතාලා ASCII codes කියලා අපි ඊළඟට ඒක පටන් ගන්නවා මේ පාඩමෙන් පස්සේ, right? So for the moment you remember like this, right? So there's an associated number. මෙන්න මෙහෙම number එකක් තියෙනවා. Different. So B ගත්තොත් 66 කියලා ගමුකෝ. C ගත්තොත් 67. මේ වගේ numbers තියෙනවා. So I don't remember the exact numbers, right? A B C. හැම එකටම special number එකක් තියෙනවා. So when you press A, so it will detect as 65. If you press B, it will detect as 66. If you press C, it will detect as 67. Right? Still, you can't send it to the CPU because it can understand only ones and zeros. අපි දැනට electronic pulse එක අමතක කරමු, right? So anyway, 1 represents one electronic pulse, 0 represents different electronic pulse, right? So here we got different numbers, right? පුතාලා දැන් keyboard එක බටන් එකක් ඔබනකොටම පුතාලා මම වෙනම number එකක් මේක ඇතුලේ වැඩ කරන්නේ, right? මෙන්න 65 තමයි වැඩ කරන්න පටන් ගත්තේ. හැබැයි එයා එකපාරට දැන් 65 කියලා ගන්න බෑ because CPU knows only ones and zeros. CPU will reject. So 6 and 5 I don't know who these fellows are, right? It will ignore. Right? 65 won't. So we need to convert this 65 into binary form. That means ones and zeros. And then CPU will understand what has been pressed. So based on the binary value, CPU will understand, oh, okay, I got A, I got B, I got plus, I got minus. So that way it will understand based on the binary pattern. Ones and zeros in a pattern, right? So we'll see now how it's formed, right? So B, C, right? Over there. ඕනම any input device, right? ඕනම input device එක it's happening like that. දැන් කොහොමද අපි හිතමුකෝ පුතාලා ගාව තියෙනවා webcam එකක්. Right? So webcam is connected to your PC. So webcam is the input device. දැන් පුතාලගේ image එක මෙයා ගන්නවා. ගන්නවා image එක. So what will happen? So this is the input device. It is capable of converting this light to ones and zeros. අන්න එකයි ඒ input device එකේ වෙනස. බලන්නකො හැම input device එකක්ම ඔය වගේ තමයි. right? දැන් මේක webcam. දැන් ගන්නවා mouse එකක්. So we can do mouse left click, right click, scroll, double click. main left click කරොත් එයා එනවා ones and zeros එක විදිහකින්, right click කරොත් එක විදිහකට එනවා, scroll කරොත් තව විදිහකට patterns එනවා, double click කරොත් තව විදිහකට patterns එනවා. So different clicks. So CPU will recognize, okay, this pattern came to CPU, so this will recognize, okay, this fellow pressed left click and this pattern came, so it will understand. So right click is done, right? So that way it will understand, right? ඉතින් බලන්නකො දැන් webcam එකත් එහෙමයි. මේක keep on converting. දැන් මම මේ cam එකක් ඉස්සරහනේ කතා කරන්නේ. So this cam is keep on converting these visuals to ones and zeros. So that's why we are using webcam. So any input device, output device, okay, අනිත් පැත්ත. What will happen, right? දැන් print එකක් තියෙනවා. Right? So we want to print some picture, right? අපිට මේ picture එකක් තමයි මේකෙන් එන්න ඕනේ. So what will happen? CPU will send information as ones and zeros. What will happen? Inside the printer there's a printing circuit of the printer head, right? And there is a mechanism where it can convert these ones and zeros to the ink dots. Finally, your beautiful image will form like this. So CPU can send only ones and zeros. There's a circuit inside the printer. It will convert that. It can understand the signals according to that bit pattern, right? It will eject the ink droplets. Tiny droplets it will tell according to the zeros and ones, right? See, that way nicely image is formed. So that's for any computing equipment. This is a procedure. Remember. So if you get thousands of input devices, we have thousands of output devices. We have, right? But the concept is same. So it will convert whatever signal to the ones and zeros. This way it will convert ones and zeros, and the output devices will convert back this ones and zeros to the respective outputs. Right? Monitor will convert ones and zeros to the images. Right? What else? What are the output devices we have? Printer, monitor. What else? One second, brother. Right. So it will convert the output devices. It will convert that ones and zeros to the images. Right? Sorry. If the printer, it will convert to the printouts. Right? So some ones and zeros battle is happening. Right? Ones and zero battle is happening. So we are getting ones and zero patterns. Right? So the device is receiving ones and zeros pattern, but everything happens according to the, so ones and zeros we can't see, right? Only electronic pulses are going here and there, but for our easiness, right? Otherwise, we can't do anything with electronic signals. So finally, we'll convert these things to the electronic signals. But to working purposes, we manage ones and zeros, right? So we have key input devices, right? It will convert the signals, input signals to ones and zeros and send to the CPU. And once the processing is done, CPU transfer these ones and zeros as output to the output devices, right? So we can get the desired output using the output devices. So this is the way of the function of the computer. මේක හොඳට මතක තියාගන්න ඕනේ, right? Right. Now, uh, now why? Now you can understand why number systems are so important, because everything is happening with ones and zeros, right? So we need to work with number systems to understand the functionality of this. In totally, it's a computer, right? So function to understand the functionality of the computer, right? Computer system. So you need to know the number systems, right? So out of few number systems, binary number system is so important because that's our base, right? That's the main number systems, not the main, right? It's the only number system computer used to process their data, right? Now in this lesson we need to learn all the number systems. So what's our natural number system? අපි මොන විදිහටද ගණන් හදන්නේ? මොකක්ද අපේ natural number system එක? Right. Just like binary, now you know binary, right? So we need to study 4 number systems. Right? Binary, octal, decimal, and hexadecimal. Right? So binary you already know, that's ones and. So this we got to study 4 number systems: binary, octal, decimal, and hexadecimal, right? දැන් පුතාලා අපි සාමාන්‍යයෙන් අපි කියනවා 26 කියලා. දැන් මේක නම්බර් එක is 26, right? So we don't place the base value here. මේක දැන් අපේ common number එකක් නේ. So මේක බලමට අපි කියනවා 26 කියලා, right? We don't say what the base belongs to. ඇත්තටම හරියටම මේක එනවා නම් 26 කිව්වම මෙතන යටින් 10 එන්න ඕනේ. So 26 is a base 10 number here. Base එක කියන්න ඕනේ. Right? Since this is our natural number system, we don't put base value. මේක මොන number system එකකටද අයිති කියන value එක තමයි මේ base value එක කියන්නේ. So how many digits it got? How many elements it got? So binary, it got, what's the base of the binary? It's 2. So that means it can have 2 components, 2 elements, right? Octal means 8. So it can have 8 elements. Decimal means 10. So that can have 10 elements. Hexadecimal is 16, right? It can have 16 different objects or elements, right? 16 entities. This is the maximum value. Here only 2, right? We already know binary Only ones and zeros now 2, right? So octal means 8, right? Uh, so what are the elements in octal number systems? That is starting from, let's say, 0 and 1, no? Right? So maximum it can have 8. So it goes like 0, 1, 2, 3, 4, 5, 6, 7, 8. It's not possible, right? Because only 8 elements it can have: 1, 2, 3, 4, 5, 6, 7, 8. That's all, right? Decimal can have maximum 10. So it can go 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 elements, right? Decimal. So this is our natural number system. Making some decimal number system, right? So hexadecimal 16. So how I try? 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. So we got 16 elements, but for our easiness, right? So 10 we represent as capital A, 11 as capital B, 12 as capital C, capital D, capital E, and capital F. So 15, so we don't say usually 15, we say F, right? A, B, C, D, E, and F. So let's write the elements again: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. That is how it's formed, right? So we got different number systems, right? Right. So you need to write down these things, right? So what are the different number systems and what are the elements associated with this number system and what's the base value, right? So we'll write some examples, right? So here itself learn some examples, right? So I'm saying 21 base 2. Can this exist? Can this exist? Putuli dua, dasani dua, tiga puta. මෙහෙම නම්බර් එකක් කියන්න පුළුවන්ද? This represents the base, right? My number के base से कितना में? So usually we represent the base of the numbers, right? So base 2 is binary number. So can binary number can have 2 here? It's not possible, ne? So only ones and zeros should exist. 1 0 1 2, that is possible, right? 1 1 1 0 0 0 1 0 2. Yes, this is possible, right? Don't worry about the length, right? But these these are non-existence characters. See, 21 base 2, which is not possible because 2 cannot have, in binary, 2 is not valid element, right? So similarly, right, 75 base 8. So this is valid number because 7 is there, 5 is there. Yes, base 8 can have this number. So if I say normally, if I don't say the base, so this will consider as base 10 number. एक आप natural लेके नहीं, right? So it's very important to say the base. So if you are representing any other base, right, you need to say the base, right? දැන් අපි වැඩ කරන්නේ පුතාලා මේ නම් ඒ කියන්නේ අපි මේ අපේ හැම ගණනක්ම මේ 0 to 9 වෙනකල් තියෙන්නේ අපිට. Right? So if you are working with octal number system, you don't get 8 and 9. So if you work with binary number systems, you won't get except zeros and ones. Right? So here, right, 75, if you don't say anything, it will consider as base 10 number. Right? So this is different than this one. Right? So be careful, right? So if you are writing some answer, if you need to represent that answer in base 8, so you need to write base 8, and otherwise they will consider as base 10. Right? So 75 base 8 can exist, but 97 base 8 cannot exist. Why? 9 is not element of base 8. Right? These things you have to remember. Right? So similarly, F9 base 10 cannot exist. No, F is not a part of the base 10. Right? 9AC is not possible with base 10, but it is possible in base 16. A and C are parts of 16, base 16 numbers, right? So you need to remember this chart before proceed. So in this throughout this lesson, we need to convert different number systems to the other number systems. As example, base 10 numbers, decimal numbers we need to convert to the binary numbers. Decimal numbers we need to convert to the octal numbers. Decimal numbers we need to convert to the hexadecimal numbers. Right? And this other way, binary numbers to octal, binary to decimal, binary to hexa. Octal to decimal, octal to binary, octal to hexa. Hexa to decimal, hexa to octal, hexa to binary. So these different forms we need to study in this lesson, right? It will take 3-4 weeks. Anyway, slowly, one by one, it's very easy. It's very easy. Right? As I told you last week, so converting decimal to binary, it's very easy. Right? So decimal number, let's say 50, let's say 44, right? So decimal 44 to binary. So that's our question. 44 10 to binary, right? So 44 decimal 42, how to convert to the binary? Just divide by 2. You need to perform successive division, right? So this is 22. Get the remainder, that is 0. Divide by 2, 11. It's remainder 0, right? Divide by 5, it's remainder 1, right? 2, 2, remainder 1, right? Check it again. 44 divided by 2, it's 22, remainder 0. 22 divided by 2, 11, it's 0. 11 divided by 5, 2, it's 5, remainder 1. 5 divided by 2, it's 1. 2 divided by 2, it's 1, remainder 0, right? So write the answer from, get the value from the uh, most bottom value, right? So this way you have to get the answer, right? Not the other way around, right? So from here you need to start, go up to the last binary number, right? That is 101 100 2. Right? If you don't say the base, it will become 100 1100, right? It's we usually tell in our decimal form, right? So this is our binary number 2, right? This one computer can understand this pattern. අන්න බලන්නකෝ දැන් අර 67 කියලා මම කිව්වනේ A press කරාදී 67 යනවා කියලා. එකපාරට 67 යන්නේ නැහැ. 67 we need to divide. So 67. අපි බලමු bit pattern එක කොහොමද යන්නේ කියලා. 67. So someone is pressing A in the keyboard, right? So associated number is 67, right? Divide by 2. 30, 32, 33. remainder 1, 2, 16, 1, 2, 8, 0, 2, 2. 33, 67 divided by 2 is 33, 66, 1, 33 divided by 2, 16, remainder 1, 16 divided by 2, it's 8, remainder 0, 8 divided by 2, it's 4, remainder 0, 4 divided by 2 is 2, remainder 0, 2 divided by 2, it's 1, 0, right? So take the bit pattern from the bottommost one, 1, 0, 0, 0, 0, 1, 1, it's 2. So when you press A, right? So this bit pattern 1, 1, 1, 2, 3, 4, 1, 1, 1. It will go to the CPU as this pattern. In other forms, it will send 5 volts, 0 volts, 0 volts, 0 volts, 0 volts, 5 volts, and 5 volts, yeah, as an electronic pulse. So we don't consider this to our uh, calculations, right? So this is our bit patterns. This is how computer will understand. So remember to put 2, right? Base 2 when you are working with the binary number. So this is the bit pattern. Computer will understand this. So CPU will recognize, okay, I got A. It won't recognize A, but it will recognize bit pattern, right? So it can assume means it knows I'm working with this bit pattern, right? So we know that is A. Right? So this is how everything is happening. So there's a associated number for each and every key in the keyboard. So likewise, so different bit patterns will go to the CPU. It will understand, right? This is how things are happening. And this is the importance of number systems. Without this, computer world won't exist. දැන් ඒක තේරෙනවනේ computer world එකක් තියෙන්න බෑ මේ number system එක නැතුව. Right? Octal, hexadecimal, yes, there are different purposes to manage hexadecimals, right? ඒක අපි තව ඉස්සරහට කතා කරමු. මොකද පුතාලා දැන් memory එකේ තියෙන space manage කරන්න වගේ ඕන වෙනකොට මේ hexadecimal form වලින් අපි කතා කරනවා. Right? ඒක දැනට මම චුට්ටක් ඒ දේවල් ගැන දැනට යන්න අපි simply ගමුකෝ අපි දැනට ඕනේ. So when you press A, what is happening? Right? We need to convert that into the binary form. How to convert that binary form? So decimal number just perform successive division by the respective base, right? Then you will get the bit pattern. So this will go to the CPU. And ඔච්චරයි. දැනට අදට කියලා දුන්නේ decimal to binary conversion එක විතරයි. Decimal to binary. Right? දැන් ඔය විදිහටමයි decimal to binary වගේම decimal to octal උත් ලේසි. දැන් 16 octal කරනවා නම් you need to perform the successive division by 8. That's all. If you want to convert decimal to octal, just perform the division by 8. You need to perform the successive division by its base. අහන්න value එකේ base එකෙන් බෙදන්න. decimal කරනවා නම් විතරයි ආ. decimal to something යනවා නම් decimal to something, so you need to perform the successive division by the base value. Right? So here I am asking decimal to binary, decimal to octal conversion. Then you need to perform the division by 8. So this is my number, right? 20, right? Right from this end, 20, it's 8. Because I have converted this decimal number to binary form. This is valid number, 2 and 0. 2 and 0 can exist in the octal form. Right? This is the මෙච්චරයි අහන්නේ. ඕකේ ලොකු දෙයක් නැහැ. මම මොකක් හරි නම්බර් එකක් දීලා කොහෙට හරි කන්වර්ට් කරන්න කියලා තමයි අහන්නේ. Right? So if you want to convert hexadecimal, decimal to hexadecimal also, that is easy. And hexadecimal එකට ගමුකෝ. 33. 39. Decimal to hexadecimal. Hexa means 16. So you need to perform the division by 16. 2 uh, 32. No, I will take 45. Okay, 45. So divide 16 by 2. It's 232 and 13. Remainder is 13. No? Right? 16 into 2, 32. Yes, 13. 2 and 13. 13 we don't write. Why? We have a letter here. That's D. 13 we won't write, right? D and 16. That's all. See here? 13 we don't write as it is, right? Otherwise it will become 2, 1, 3, 16. So this is wrong. This is something else, right? This is valid number, but this is not the one we expected, right? So 13 we need to isolate. 2, 13 means D, 16 you have to write. So don't take like this. So it will confuse, right? Here itself you get the conversion, right? So substitute here itself to the D and put the base. So that's all. හරිම ලේසි. ඕනම ඩෙසිමල් එකක් ඕනම කන්වර්ට් කරන්න ඕන නම් ඒ බේස් වැලියු එකෙන් බෙදාගෙන ගිහිල්ලා ඒ වැලියු එක යටම නම්බර එකේ ඉඳන් টপ බොටම් මොස් වැලියු එකේ ඉඳන් උඩට යනකල් බිට් පැටර්න් එක ලියන්න. That's all. බලන්නකො දැම්මම කීයක් ඉවරයිද කියලා. right? Decimal to octal ඉවරයි, decimal to binary ඉවරයි, decimal to hexadecimal ඉවරයි. So other around binary to octal, binary to decimal, binary to hexa, that's also easy. හරි. අපි මේකේ දැන් අදට මේක ගන්න තව එක්සර්සයිසස් ටිකක් කරලා මේක ෆර්ම් කරගමු next time එකේ. right? මේ ටික අපි පළවෙනි සතියේම decimal binary conversion එක කරමු. ඊට පස්සේ අනිත් දෙකක ඉතුරු ටික ඉවර කරලා මේ මාස by August end වෙනකොට අපිට මේ පාඩමත් ඉවර කරන්න පුළුවන්. right? එහෙනම් so we'll wind up for today, right? So it's 9:10, right? Then we'll see you next time. Right? I want to Tala. Good night.